students, to discuss some important concepts also. Now we are going to see the centripetal acceleration. So the best example of centripetal acceleration, when an object covers the distance in a circular path with varying the velocity, that is change in velocity, okay, with respect to time, that is known as centripetal acceleration. The force which is towards the center, then object covers the distance with the varying velocity, that is called what? Centripetal acceleration. Now we are going to derive one important equation related to the centripetal acceleration. Student, now see this diagram. Initially the velocity of a particle is v1 and the position vector is r1. After some interval of time, the object covers the point, the velocity reaches that is v2 and the position vector is r2, which is making an angle is theta. Now we are going to frame the relation between position vector and velocity vector. Okay. Consider theta is the same angle and del t is the time interval taken by the object moving. So finding the position vector, so r is equal to modulus of r1 vector equal to modulus of r2 vector, because the both radius will be same, and velocity v is equal to modulus of v1 vector equal to modulus of v2 vector. First of all, we are going to find the what is the change in displacement. So using the position vector, I am going to find the change in displacement, that is del r vector equal to r2 vector minus r1 vector. Similarly, for finding the change in velocity, we know del v vector equal to v2 vector minus v1 vector, that is from the final vector minus initial vector we are subtracting. Then we have to use the relation between the position vector and the velocity. We know del r divided by r equal to minus del v divided by v. So the total, the velocity will be equal to angle theta. And the negative sign here represents the position vector is radially inverted. That is, when the velocity will be toward inverted, the value should be in minus. So we find the change in velocity del v is equal to, and the v will multiply in the right side, we get minus v into del r divided by r. Then I am going to divide del t in both equation, that is both the left side and the right side of the equation. I get del v divided by del t equal to minus v by r into del r divided by del t. Then since we know del v divided by del t equal to a, that is acceleration, and del r divided by del t equal to velocity v, and substitute in this equation, we get a is equal to minus v square by r. Since we know the formula velocity v is equal to omega into r, and substitute in this equation, so we get a is equal to minus omega square r square divided by r, and cancel numerator and denominator r, we get a is equal to minus omega square r. This final equation represents the relation of the centripetal acceleration. A very important concept, students. Students, now we are going to see the for the centripetal acceleration in the non-uniform circular motion. Okay, we know the non-uniform circular motion means an object covers the distance with varying the velocity. Okay, see the example. When the bob attached to a spring moved in a vertical circle with the speed of the bob is not same at all the time. Whenever the speed is not same in the circular motion, the particle will have both centripetal and tangential acceleration. That is, when it is rotate, the bob will have attains both centripetal and tangential acceleration. That is, there will be some change in speed of the bob in moving in a circular path. So we are going to derive the what is the centripetal acceleration relation. You see this diagram, then you can easily understand the centripetal relation. Okay, now an object covers in a circular path towards the center, the centripetal acceleration will be act, and r represents the radius of the circular path. and AT represents the tangential acceleration. Here the AR represents the resultant acceleration, that is the final acceleration which will be in between the tangential acceleration and centripetal acceleration. The theta represents the change in the acceleration value. That's why we are going to find here using the relation. Students, so consider AC represents the centripetal acceleration and AT represents the tangential acceleration and AR represents the resultant acceleration. From the diagram we are going to find. Since the AR is equal to, we know the formula, resultant velocity formula, V is equal to square root of Vx square plus Vy square. The same relation we are going to use here. Therefore AR equal to square root of AT square plus AC square. Since we know AC square value, the AC square is equal to, AC equal to V square by R, and substitute in the formula, we get AR equal to square root of AT square plus V square by R the whole square. So this resultant value represents the resultant acceleration of an particle moving in a non-uniform circular motion. Then we are going to find the, what about the angle between this acceleration? Therefore, the resultant acceleration makes an angle theta with the radius r in the vector. Therefore, we know the formula that is mentioning the direction. So, tan theta is equal to AT divided by AC. Since AC is equal to V square by R, substitute in this equation we get tan theta is equal to AT by V square by R. Since we need only theta, therefore we get tan inverse of AT divided by V square by R. Student, using these two formulas, that one is AR equal to square root of AT square plus V square by R the whole square, and another one is theta is equal to tan inverse of AT by V square by R. So very important formula while solving the problems. We see the example related to this formula. Students, now we see one example problem related to the non-uniform circular motion. So example 2.40. See the question. A particle move in a circle of radius 10 meter. Its linear speed is given by v equal to 3t, where t in second, where v is represented in meter per second. So we have to find centripetal and tangential acceleration when t equal to 2 seconds. And second one, calculate the angle between the resultant acceleration and radius of the vector. So very important problem, students. An object covers the distance in a circular path of radius is 10 meter. The speed is 3 meter per second. Okay, when time will be changed, the speed also change. For that, they represents the t equal to 2 seconds. So we have to find two things. One is centripetal acceleration and tangential acceleration, and second one, what about the angle between the resultant? Okay, so which we discuss right now. So we solve the problem. So first you write the given data. In given, you just write the linear speed. So v is equal to 3t and radius r equal to 10 meter. Okay, so first we solve the centripetal and tangential acceleration. So to find this value, first we have to find the velocity. Okay, so substitute the t value, t equal to 2 seconds in 3t, and we get v is equal to 2 into 3, so nearly 6 meter per second. So to calculate the centripetal acceleration, we know the formula, that is AC is equal to V square by R. Since we find V right now, so we get 6 square divided by 10, and we get 36 divided by 10, and we get the final answer is 3.6 meter per second square. The unit is very important. If you fail to write the unit, they reduce half mark. Okay, so the AC is equal to 3.6 meter per second square. Then we find the tangential acceleration AT. Also we know the formula AT is equal to dv divided by dt, and substitute v is equal to 3t, and we get d divided by dt into 3t. So we get the answer is 3, because dt cancel each other. So only we get the AT is equal to 3 meter per second square. next we are going to find the relation between, that is the angle between the resultant acceleration and radius vector. So we know the formula, tan theta is equal to at by ac, and substitute the value. So 3 divided by 3.6, we get nearly 0.833. Since we need only the angle, so the tan will be moved in the right side and become inverse. Therefore theta is equal to tan inverse of 0.833. Using the natural tangent value, we can find this answer. Okay, so therefore theta is equal to 0.69 radian. So we have to convert that radian into degree. So we know the constant value, which is 1 radian equal to 57.27 degree. So I'm going to multiple in here. So convert it into degree. Therefore theta is equal to 0.69 into 57.27 degree. So nearly we get the angle is 40 degree. Therefore the angle between the resultant acceleration and the radius vector is 40 degree. So very important problem, students. So go through very carefully. Students, now we are going to very close to end of this lesson. So already we know the linear equation of motion, 3 equations which we studied in the Zoom class. Here we are going to use the same equation of motion, not in linear, it is in the circular. When an object covers in a circular path, so what about the equations we are using? Before we going to see that equation, you know some important terms and the unit. So first you see the linear displacement. It is represented by S, the unit is meter m. Similarly, the angular displacement is theta, the unit is radian. Then linear velocity v, that is meter per second. Therefore angular velocity is omega radian per second. Then linear acceleration a, meter per second square. Then angular acceleration alpha, unit what, radian per second square. Then linear momentum, we know p, unit is what, kilogram meter per second. So angular momentum is represented as L, unit is what, kilogram radian per second. So these are the some important concepts you have to remember in this lesson. Now we move to the 3 equations of the kinematic in a angular. Okay, so first thing, you see this table. So differentiate, okay, both will be same. So here the first equation is represented, omega is equal to omega naught plus alpha t. Okay, here the omega represents the final velocity and omega naught represents the initial velocity, and alpha represents the angular acceleration and t represents the time taken. You just compare with the linear equation. I teach only the angular right now. Then second equation, theta is equal to omega naught t plus of alpha t square. So theta represents angular displacement, omega naught represents initial velocity, and alpha represents the angular acceleration. And third one, omega square equal to omega naught square plus 2 alpha theta. So omega represent here is final velocity, omega naught represents initial velocity, and alpha represents angular acceleration, and theta represents angular displacement. And last one, theta is equal to omega naught plus omega divided by 2 into t. So theta represents the same angular displacement, and omega naught represents the initial velocity, and omega represents the final velocity. So this is very important, students. You may expect in 2 mark question, write the kinematic equation for angular motion. So go through well. And one more thing, so today evening you are going to write your first midterm test in higher secondary. So don't copy when you are writing, and don't blame yourself. Be truthful to you. If you have any doubt in what we are teaching, you just contact your physics teacher. Okay, so write all the questions, don't omit any single 1 mark, try to attend all the answers. Okay, and neat presentation should be in our physics paper. Use scale and pencil, okay, while drawing, and don't overwrite. So whatever question asked in today's midterm test is exam oriented only, we are given to you. So after completing this midterm test, You all write one time this question paper without choice and submit to your physics teacher, because for your internal assessment mark. Don't forget it, students. So after completing the midterm test only you are going to write. So see and write and submit neatly. Use the A4 sheet. Okay, thank you. All the best for your midterm test.